Hey everyone. So the objective of this video is to show you how to draw this structure. So it's a 50 nucleotide window on a mRNA that was folded in RNA structure with reactivity constraints. And then I took that CT file, which stands for connectivity table, and I used that CT file and the reactivity data to make this structure using my computer, and the colors behind these nucleotides, the intensity of the pink corresponds to how reactive that nucleotide is. So you're going to want to have two windows open to make this structure. The first is R. I'm going to use RStudio because I like it. And this is how we're going to generate structure drawing inputs for R2R without manually editing a lot of text files. And then you also want to have a bash terminal open. I'm a Windows user, so I have to use something like Cygwin or Ubuntu for Windows to run bash stuff. But obviously Mac and Linux users can just use their bash terminal. And so this is where we're going to run R2R on the outputs of the stuff we're going to generate with R. So going back to R, we're going to get started. So the first thing I'm going to do is make an R script just to keep my code organized. I'm going to save it in the directory with the data. There's a CT file here and there's a .shape file here. So I'm going to save it in the window, in the directory with my data. And then the second thing I'm going to do is I'm going to set my working directory. So I'm going to go up to Session, Set Working Directory, to Source File Location. And down here in my console, this little line of code ran. And I'm just going to copy it and paste it up here in case I want to use it later. The next thing I'm going to do is I'm going to install the code from my package R2easyR that we're going to use to generate the R2R inputs. So the command to do that is devtools, which is a kind of a package of development tools in R. And I'm going to go install GitHub. And then my package is jpsig, which is my username, and the repository is R2easyR. And this line of code should download R2easyR onto your R console. So it's going to spit an error message like this at you, maybe. I'm not that great at coding. Might want you to update all of these packages. I'm not sure why. I'm not really great at making R packages. Don't do it. It's going to take you forever and it doesn't do anything. So I'm going to enter an empty line to skip all those updates, and it's going to install just fine. And there, we're done. The next thing we're going to do is load our R2easyR installation from wherever it installed into our memory, so we can call it easily. So R2easyR library R2easyR, and that happens real quick. The next part is we're going to load in the CT file. So load in CT file. And we're going to make it a data frame, so df. And then we're going to use a command called read.ct, which is an R2easyR command that reads CT files from RNA structure, whatever. And if we do list.files, because I forget what it's named, down here in our console, we can see this is the CT file I want to run things on. So I'm just going to copy and paste it into here. Right? And if we go view, so here it looks like it loaded correctly. I'm just going to go view, DF, get into this a little more in depth. And we can see N is the residue number. Nucleotide is the nucleotide. And then N-1 is, so 800, N+1. I'm not going to explain that. You already get it. Then finally, the connectivity table, the CT file, specifies which nucleotides are base pairing with each other. So C807 in this structure is base pairing with residue 841. So after that, we're going to use the information in this CT file to generate a dot bracket notation that R2R can actually read. So we're going to add dot bracket. And basically to do this, we're going to go df equals add dot bracket, which is an R2easy command, applied to df. And now if we go ahead df, we'll see we got a new line of dot bracket information, which is kind of nice. We're actually going to look at the whole thing so you can see it. So yeah, here we have carets and dots in the right place so that R2R can read the secondary structure. After that, we're going to load in the reactivity data. So there's kind of two common RNA lab file formats that you might encounter. The first is a React file, and there's a function for that in R2easyR. So read react, right? So reads a .react file. This might come out of like structure seek or something. The second is a .shape formatted file. So read, this is the kind of format that RNA structure uses. So read dot is another one. And this is the one we're actually going to use. And I'm pulling up the help files using the question mark now. You can see there's not a lot to it. So next, we're going to go, we're going to read our shape data. We'll just call this shape using read dot shape. I've already forgot the file name, so I'm going to go list dot files to find it. And here it is. Okay. Uh-oh. Duh, I put it in the wrong spot. There's going to be some usage warnings because the way I had this file, the missing values said something weird. It was coerced, the program coerces them into being NA, no value there. So after that, I can put it in my data frame. So I'm going to go data frame, $, reactivity to add a new vector, which is just basically a column to that data frame. Shape, because shape is currently, if we run it, shape is just a vector. So adding a new vector full of reactivity data into DF, and if we look at our data frame now, it has all the reactivity values you need. So after that, we're going to generate our R2easyR palettes. So generate palettes. And that's pretty easy. I'm just going to make an object called palettes. And it's going to be called, and the function I'm going to use is R2easyR palettes. And now we have a list of palettes. And then if we go $, you can see them all. What I'm going to use for this example is purple red.c. Here it is. So this is the palette we're going to use. It's just a vector of colors. And then after that, we're going to color the nucleotides using the kind of reactivity color mapping function. So color nucleotides. And the function we'll use for this is R2easyR.color. I'm pulling up the help file so I can see the usage. It's called R2easyR color because it colors nucleotides. Not that creative. So we're going to make data frame because we want to add this information to our data frame. And we're going to go R2easyR color. And my first argument is the data frame we want this to act on. So we'll go df. My second argument is the palette we want to use. Getting that information from over here. I'm not going to mess around with the absolute reactivity threshold, with no data, but I am going to change the absolute reactivity threshold to 0.1. And this is just so the really low reactivity data isn't cluttering up the structure. For example, a reactivity of 0.01, it's basically 0, and I don't want to look at that. So I just want to make a comment on this argument right here, manual scale. You can set a manual scale. And you might want to do that for two reasons. The first is if you want to compare reactivities between two RNA, you probably want the scale to be the same, so that the same reactivity will correspond to the same structure, the same color in both structures. Another reason you might want to set a manual scale, this data is actually pretty good. So, it goes from 0 to 2, and there's not some crazy outlier like 50. There's not one reactivity in the data set that is 4 or 5 times as large as the rest of the data. But if you have that situation, that really high reactivity data is going to appear really intense, and it's going to wash out all of your other colors. It's going to be hard to see. So basically, you want to set your manual scale to go from 0 to something like 2. And if there's some value that's up around 50, it's just going to be colored like it's 2. And that way it's not washing out all your colors. So now we're going to go ahead and run this line, R2easyR colors. And if we look, it's done running. If you look in our directory, you can see we got a couple new things. First of all, we have a list of palettes. You can look at that if you want. We have a legend that you can use. You can open this in Illustrator or PowerPoint or some PDF editor, and you can copy and paste this legend next to your secondary structure. So that's kind of nice. The second thing we got is a reaction plot, which will show you before you draw the secondary structure what the data is going to look like with its color. So here there's a value up around 1.6. It's really reddish pink, and then down here you've got this very light purple color for low reactivity data, and I think that's going to look nice on the eventual structure. moreover, when we go df, you can see we got two more columns on our data frame. The first is labels, and this just tells the writing function, should I write color values for this nucleotide or not. The other thing is the color. So this is what color do we want each circle or letter to be on the RNA secondary structure. So the last step we'll do here is we're going to use a function to write R2R inputs. So the function to do that is R2easyR dot write. So I'm going to pull up the help file, and I see my first argument is going to be the output file. So R2easyR dot write, and I want my output file to be named demo. What data frame I want to do it on, it's going to be df as the second argument. I'm getting that from over here. I'm not going to change the RNA name. I'll just let it be the default, which is default. Doesn't really matter. But I am going to specify for colors argument, I want it to be circles, which means circles behind the nucleotides. The default option in A is not going to print any colors. You can also color the letters, which might look good, might not. But I think the best option is just to set this to circles. And then I'm going to go ahead and write. So now if I look in my directory, I got two new files. I got a Stockholm file, which is formatted for R2R, and it contains all the drawing information. And I have a R2R meta file, which is kind of the program that R2R reads to read the information in here and draw the structure. So at this point, I'm done in R. I'm going to save my script. I'm going to go over to Siglin, my bash terminal. I'm going to run R2R on demo. So I've navigated to the correct directory. Here's my demo R2R meta file. And I'm going to call R2R. So R2R, I'm going to go disable usage warning. And this is because I'm not drawing a consensus to secondary structure, and this usage warning only really applies to a consensus secondary structure. And then demo.r2r meta is the meta file that I want to run R2R on. And then my output is going to be demo.pdf. And if I open up my folder, I now have a PDF called demo that contains this nice structure for us with the reactivity data from the DMS probing experiment mapped to the A's and the C's. Yeah.